So the Nanoionics and Electronics Lab here at Pitt, we develop new types of electronic devices based on materials at the ultimate limit of scaling. So these are materials that are a single atom or molecular layer thick. And so to put that in perspective, that's the equivalent of 10,000 times the thickness of a hair on your head. And we control the electrical and mechanical and optical properties of these materials. And the key ingredient that we use are ions. So you're probably familiar with ions in your rechargeable lithium-ion batteries, in your iPhones, and your laptops. We use those same materials but apply them into electronic devices like transistors for logic or memory. And the idea is to not only enhance the electronics you're familiar with, so make your battery last longer in your laptop, for example, because we use low power transistors, but also to invent entirely new device concepts. When ions interact with these molecules, they give an electrical signal that's very similar to the neurons that fire in your brain. And so there's a lot of interest in so-called brain-inspired computing. And this work really happens at the intersection of multiple disciplines. So this is chemical engineering, electrical engineering, material science. We work a lot on developing new types of memory at the, again, ultimate limit of scaling. So imagine being able to put a huge amount of information onto something that's a fraction of the size of one of your thumb drives, for example. So these are the types of goals that we'd like to see. We are at the very forefront, the inception of these ideas, and to be able to take them the whole way to commercialization would certainly be the ultimate goal. So the students in my lab are trained on pretty sophisticated nanofabrication techniques because, as you can imagine, to manipulate these materials that are single molecule thick, you need to have pretty sophisticated techniques. So a lot of nanofabrication to create these devices on very small length scales. So one of the things I appreciate the most about this department is it's a very energetic, excited department about research excellence and teaching excellence. And so I feel very supported here. I feel like if I come up with a really ambitious, exciting idea, that if I can justify it, that I could get support, I could get my colleagues to rally around me and have support for that idea. And I think that's a little bit unique compared to some other departments that I've seen.